Okay, guys, sorry for the interruption, but there are certain calls that I just will not miss. Once one of college roommates, it's an automatic. Pick it up. Pick it up. All right, here we are. So, back to this, okay? We have to do one of these two things, okay? So, show the probability of A is equal to the probability of A given B, or the probability of B is equal to the probability of B given A. So I'm going to do this two ways, okay? I'm going to do it with just the chart here. Just, I don't say chart. Do the table here, and we'll do it with the formulas down here, okay? So by the table, the probability that they have allergies. Well, let's look. Probability they have allergies is 18 out of 40, okay? And I want to see if that's equal to the probability of allergies given they're a female. So if they say given they're a female, I'm looking at just the ladies, just the females. Okay, so we're here in the females. Given they're a female, what's the probability of allergies? That's 10 out of 23. Well, this doesn't look like it's the same, but I'm going to use the calculator to confirm. Okay, the calculator is going to confirm this information for me. So let's do 18 div 40. I get 0.45. And then I do 10 divided by 23. And I get 0.434. So that's going to be 0.43 really, okay? And you're going to say, well, wait, that's close. Is that good enough? No. So we are going to say not independent, okay? Let's see if these other things are going to confirm that answer for us. So the probability that they're female, how many females do we have? 23 out of 40. And I want to see if that's equal to the probability they're female given they have allergies. So given they have allergies, I'm looking at just the allergies. Probability they're female is 10 out of 18. Okay, let's take a peek at that. 23 divided by 40 equals 0.575. And then 10 divided by 18, 0.5556, so that's 0.56, not. Okay, so far we're good. Now let's do it using the formulas. Okay, the probability of A, probability of allergies, 18 out of 40, that hasn't changed. Now, the formula for the conditional probability is right here, and that says the probability of A and B divided by the probability of A. Okay? So let's look. So I want to see if that's equal. So probability of A and B. So what's the probability of A and B? That means they're female and they have allergies. That's 10 out of 40. Okay? That's my numerator. That's that. Divided by the probability of A, which is the probability... Oh, I'm sorry. Probability of B given A. So this is the second one. Okay? So that's the probability of B. That's the probability they're a female. So let's look at that one. Female is 10 out of 23. So dividing is the same as multiplying by the reciprocal. So we go 10 over 40 times 23 over 10. And we see that we get the same thing, 23 out of 40, that we got over there somewhere. But we're going to see that's not the same. 23 divided by 40 equals 0.575. 18 out of 40, 18 div 40 equals 0.45. Okay, not the same. So therefore, still coming up with not independent. Let's just review this, okay? Probability of A given B, which is the probability of both, okay? And then divided by the probability of B. See how it says this? First B, then A, okay? So this is second. That goes in my denominator. Okay, and then we have A and B. If I did probability of B and A, it would be the same thing. All right, but not. Okay, so if I did this one, probability of B, that's females, 23 out of 40. Is that equal to this? The letters are in the same order as this. Probability of A and B, again, that's our 10 out of 40. That's my numerator, divided by the probability of A, and that's allergies, which is 23 out of 40. So I multiply by 40 over 23, and I get 10 over 23, and we know that's not equal to that. So we did it every which way. Every which way. You have to pick one of them, just one. Don't do it 4 times. I just wanted to show you how to do it. I want you to have a good understanding of the x. It's frequently on the actual test. Okay? So let's look at this next one. Next one. Draw a tree diagram that shows the sample space for this chance process. Picking 2 sneezers. Okay, so let's look at what this says. In the previous alternate example, we used a two-way table that classified 40 students according to their gender with allergies. Okay, here's the table again. Yep. Draw a tree diagram that shows the sample space for this chance process. Choose 2 students at random. Okay, so we randomly select a student. And what are we worried about? We're worried about allergies. Okay, so if we randomly select a student, ready? Randomly choose a student. And we're really concerned here with allergies. So that's what we're talking about, right? Talking about whether they had allergies. So we'll say that the top one is that they have allergies. And then here we're going to say no allergies. Okay, so if they have an allergy, the probability is allergies, 18 out of 40. And then they don't have an allergy. Well, if it's 18 out of 40, they don't have an allergy. That's no allergies. That's 22 out of 40. Okay? And then we're going to choose another student. Now this is going to be important. I hope you're paying attention. All right? Now, we're choosing 2 students at random. So after we choose that first student, okay, these one have, and so we're going to say have no allergies, have no allergies. Okay, so let's get back to this here. Ready? If we choose a student at random and that student has allergies, how many students are left? Because we're choosing 2. That means we're choosing them at the same time, okay? Choosing 2 students. So if we choose one, there's 40 of them, that's the probability. If we've already chosen a student, that means we've got 39 left, okay? And if our first student that we chose have allergies, then how many still have allergies? If we choose one, okay, there's 40 students. We know 18 out of those 40 have allergies. If we pick that first one and they have allergies, and we go to pick another one out, there's only 39 kids left. And if the first one had allergies, then there's only 17 left that have allergies. Okay? Now, we pick that first student, okay? There's 39 left. This one has allergies, so what's the probability of getting no allergies on my second one? Well, let's look. No allergies was 22 out of 40, so this is going to be 22 out of 39. That's to get no allergies. You choose the first student. They don't have allergies. How many students are left? 39. How many of those don't have, okay, if the first one doesn't have an allergy, then how many here have allergies? That would be 18. Okay, you choose the first student. They don't have allergies. There's 39 left. This one doesn't have allergies. How many are left that don't have allergies? That would be 21. Okay, so there is our chance process. Okay, find the probability that both students suffer from allergies. That means they have allergies and then they have allergies, right? So we're going to take this and multiply times this to get here. This times this to get here. This times this to get here. This times this to get here. However, they already asked me, what's the probability they both have allergies? Then I'm just doing this times this. So it's going to be 18 over 40 times 17 over 39. Okay? And I believe that is going to be 0.196. Okay? So that's how you set that up. Let's go on to the next one. Moving right along. Okay? Playing in the NCAA. It says about 55% of high school students participate in an athletic team, and at some level, and about 5% of these athletes go on to play in a college team. It's such a big commitment when you go to college. Everybody does it in high school. Yeah, it's the popular thing to do. When you go to college, it's rare that you find, it's hard. no one's going to your games. There's not that many. The whole campus doesn't go to your games. You know, like it's a lot harder. You have to be really committed to do that. So there's nothing wrong with playing in high school and then not playing in college. But if you really love it, then do it. We've had some students do it. So again, let's look. What percent of students play a sport in high school and go on to play a sport in the NCAA? So let's say this is high school. We get the high school student, and there's a 55% chance they play, which means there's a 45% chance that they don't play in high school. And then it says 55% of high schools participate in a high school athletic team, and about 5% of those athletes go on and play at a college team. So that means that 5% of those play on a college team. That would mean that 95% don't. So the problem is, what percent of high school students play a sport in high school and go on to play a sport in the NCAA? So we're going to do 0.55 times 0.05. And I got 0.0275. 0.0275. Okay, so about 3%. All right, here we go. We're going to keep cranking out. It's probably going to stop me. Maybe I should stop now. I don't know. Maybe we will. We'll stop here. Okay, we'll cut it loose and then we'll pick up on the rest of this. I still got a bunch of pages here. So it's probably going to be a few videos when you guys go to watch this. I haven't timed it, so I don't know how long it's going to take us, but I guess it's a good place to pause.